Here we have the whole universe of numbers organized and classified. And we're going to do some problems that have to do with classifying numbers. This big oval right here represents all of the real numbers, numbers that are real. And we make this category because there are numbers floating around out here somewhere that are imaginary. You may not have seen these yet, but this is what happens when you take the square root of a negative number. You get this kind of imaginary number. We use the I notation. Probably don't need to worry about that right now, but just know that it's there. And sometime in the future, you'll probably get to learn about it. The real numbers is where we spend most of our time, and the real numbers can be divided into two main categories. We have rational numbers over here, things like these decimals, and then the various classifications of integers, and then the irrational numbers. What makes something an irrational number is that it can't be expressed as a fraction. There's no fraction, no one number you could put over another number to express it. These are some odd characters like the square root of 2 and pi, and maybe you haven't seen e yet, but you will. When you punch these into your calculator, the decimals go on forever and they never repeat. So that's a sign that something is an irrational number if you get a never-ending, non-repeating decimal. Over here in the rational numbers, we have our regular decimals. This one goes on forever, but it repeats. It's 0.777. So as long as there's a repeating pattern, it's rational. You can express it as a fraction. And then we have all of the numbers without decimal parts. These are integers. So integers include all the negative ones, all the positive ones. Actually, 0 is neither negative nor positive, so it includes 0 too. And then we have what's called the whole numbers. That's the integers without the negative ones. So from 0 on up to infinity with no decimal part. Those are whole numbers. Another category we have is called natural numbers. We can think of these as the counting numbers because it excludes the 0. So you start at 1 and go up. So 1, 2, 3, 4, 5. Those are the natural numbers. And then one other classification we can make is the digits. That's just 0 through 9. All of the actual numbers that make up all of our other numbers are the digits. So those are the classifications. We'll come back to this when we need to, but let's look at a couple of problems here. This first one says, what's the best classification for 0.6? So 0.6. Well, here's 0.6, so it's a rational number. It's a decimal, it's a real number. Let's see if we can find something like that. So, well, it's not an integer, so A is out right away. B, rational number and real number. It is both of those things, so that might be it. It's not irrational. This decimal would have to go on forever to be an irrational number, so it's not C. And, well, it's not a whole number because it has a decimal part, so it's not D. So must be B, a rational number and a real number. Let's try another. So this one says, which of the following is true? The number 17 is a digit. That's not true because the digits, this actually has two digits, the 1 and the 7. The digits are the individual numbers, 0 through 9. B says 0 is a member of the set of positive integers. And this is a tricky one. You might be tempted to say that that's true, but it's not because 0 doesn't have a sign. It's neither positive nor negative. All right, and this one says the set of natural numbers is 0, 1, 2, 3. Well, that's actually not right either because natural numbers are counting numbers and we don't start at 0 unless you're a computer scientist. We start at 1 when we count typically, so that's not true. And D says irrational numbers are real numbers. That's true. Remember, this big category is the real numbers and irrational numbers fits under that. So that one is true. Let's try another. All right, this one says which of the following is false? Okay. The set of whole numbers is 0, 1, 2, 3. That's true. Whole numbers start with 0 and go on up. They just exclude the negative integers. B says the set of natural numbers is 1, 2, 3, 4, etc. This dot, dot, dot means you continue on in the same direction. That's true. Those are the counting numbers. C says all rational numbers are real numbers. And that's true too, right? Because rational numbers all fit inside this bigger category of real numbers. Well, it better be D. The set of integers is dot, 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 -4, -2, 0, 2, 4, dot, dot, dot. So this continues on in both directions, down into the more negative, up into the more positive. And those are integers, but they're not the set of all integers, which is really what this is saying, because it's missing the odd ones. If I had to describe this, I'd say this is the set of even integers. So that is our false one. And that's our answer. All right, one more. This one says, what is the best classification for the square root of 13? And we've got things like integer, rational number, real number, irrational number, real number, whole number, integer, real number, rational number, real number. I think the best place to start with this one is on a calculator. Let's actually take the square root of 13 and see what we get. So 13 square root, and we get this 3.605551275. So this looks like a number that goes on forever, and I don't see any repeating pattern in here. So this is a non-ending and non-repeating decimal. That is our definition of what an irrational number is. So the square root of 13 fits right here. And let's see, irrational number, real number, that's the best description for it. So that's a little bit of work with classifying numbers.